Thank you, and thank you everyone for attending this presentation about Capella. So that's the tool I will tell you about today. I'll start with just a few words of introduction. So I'm Martin and I work for Obeo. So for those who don't know, we're a software editor from France. We contribute a lot to the Eclipse community. We've been working on Eclipse projects for a couple of years now, I think over 15. We're usually specialized in modeling technologies. So modeling technologies have, you know, a lot of different, like a very wide scope of applications. But today, I will tell you about one of the modeling tools we're working on, which is Capella. It is a tool that is focusing, like an MBSE tool, focusing on the modeling of complex systems architecture. So the challenge behind Capella is difficulties that are met usually by system development engineers in pretty much all industries. So we all know that systems nowadays are becoming increasingly complex with a lot of different components that involve many disciplines. So huge teams who need to define and specify all these countless components with all their interfaces. And this gets really challenging to do with traditional approaches that rely on textual descriptions in documents because they're really hard to maintain, and there can be a lot of challenges that appear, like inconsistencies appearing really quickly when there are changes, and so this is one of the challenges that are really common in companies that develop complex systems, especially in automotive industries at the moment. So to present it in a way that maybe talks to everyone based on the V models, what we're looking for then, because usually the user requirements, they kind of have to be textual because it is the way you will interact with a user who doesn't know about the technique, or you have to start that way. And what Capella offers is a way to transition from textual user requirements to detailed tools that focus on specialty engineering in the downstream process. So it will act as a complement to enhance your textual descriptions of your system based on relying on models, diagrams that are way easier to read and to analyze. To give a little bit of context and retrace the story of Capella, it was first developed at Thales, so in the aerospace and defense industry. They started building it in 2007. Their first deployment was in 2009, so at the beginning it was mostly thought as an internal tool. But a couple of years ago they decided to make it public and open source, and it became an Eclipse project. And since then it's been spreading around, and it's now kind of widely used. I will talk about it a bit later. So first of all, as was telling you about the question behind Capella, which is how engineers can transition from these textual descriptions to those tools for specialty engineering. Before thinking about a tool, you have to wonder to find out how you will do it, and that is to find a method to help you do that. And this method, it was also developed by Thales, and it exists. It's called Arcadia. It's a method that is tightly coupled with Capella, and its goal is to provide a description of the systems in the form of these models that are shared and that can be used by all stakeholders, specialty engineers, users, everyone. So they would use these models as a reference, and these models would become a single source of truth for them to use. I won't get into the details of the method, but just to give you a quick overview, it is structured in 4 perspectives that are divided in 2 kind of parts. So the first one, in the first part, you will see the system as a black box. We like to call it the problem space. So you will define the operational context of the system and then decide and model what it will have to do without describing yet how it will do it. And in the second part, you will see it as a white box, so you will make your technical choices about how the system will work and how it will be built and so on. And in the end, you will end up specifying all those components and interfaces with models that will act as contracts for the later development teams. To make it more concrete, here's an overview of the concepts that are used in Arcadia, which are the objects you will model using that. So it starts with capabilities, which are high-level descriptions of what the system will do. Capabilities are composed of functional chains and scenarios, which involve functions. So functions is really the central concept in Arcadia. It's really a kind of fine-grained descriptions of what the system will do. Functions are bound together by functional exchanges, and they're implemented by actors and components, so they're allocated to those actors. And there are also concepts to model component exchanges, so exchanges between components, interfaces, mode, and states. So you see that with a very limited number of concepts that are also quite easy to understand, you can take them, and depending on the perspective you are in, so yeah, remember the Arcadia method was divided in 4 perspectives. If you take those concepts and decline them slightly, so for each perspective, the same concepts will be there, but have slightly different meanings, and that way you can have a really complete model of everything you need to do this transition, so from the textual requirement, then model the operational context and what the system will do, then how it will be built. Doing this, applying this method, it has several advantages for engineers, systems engineers, and also all development teams. So I will come back to the other slide, and you see the arrows that are vertical. It means that between the perspectives and during all the process, you will keep traceability links between all the items. And so having these traceability links, you can connect them later to test cases and so on. And all of this will simplify the integration, verification, validation activities. You can increment your system. You have, this kind of digital twin, this beginning of a digital twin of your model, of your system, which you can, modify if you realize that things don't work. So you can usually easily increment your model, and then, that way you can adapt your specifications to changes or mistakes that were made. And finally, or actually it's not finally, because there are several other benefits, but one that I would like to show is that it will simplify product line engine modeling, because you can model also variations of your systems architecture. On this slide, I would like to say that all the rest of the functionalities I showed before are part of the open source core. This part is not, well, it's another company that developed some add-ons that make it possible to do that directly in the model. Otherwise, you would have to use some custom add-ons or to extend a bit the tool. So once you have the method, you can start thinking about the tool, and the tool is, as I said, Capella. Capella is really the Eclipse-based Eclipse project that was designed to support the application of the Arcadia method. It was developed, as I said, by Thales. In the history, it was developed really by systems engineers, for systems engineers, who really wanted to make their everyday life easier and to have an easy way to model their systems that would actually help them. So Capella was really designed to have a lot of modeling accelerators that you see here. So coupling with the method, as I said, replicable elements to make libraries of model parts that you can reuse, and a couple of things like that, that makes it really easy to use and that really supports the modeling activities. And since it's really made to support the application of the method, it's also made to really provide all the representations you would need in addition to supporting all the required concepts. And so it provides really a wide variety of diagrams to model behaviors, function data flows, other behaviors, interfaces, structures, architectures, allocation of functions to actors or components, and everything like that. It is also a great tool to start deploying systems engineering and MBAC in teams, because since it has this coupling with a method, it also provides a feature that you see here. So this is an actual screenshot from Capella, and you see those arrows that will guide systems engineers who are starting to build models, and that will really suggest them the diagrams and representations they might need. And that way, you will always know what you're doing and why you're doing it. So yeah, this is, to summarize, so what makes Capella different is that it's really pragmatic, open source, free, easy to use, and already. So it really helped Capella to be successful. As I said, it's been open source and public for a couple of years now. And nowadays it's really a reference in the world of systems engineering and MBSE. So we know over 700, I think, users or organizations worldwide that use Capella. And well, as you see here, a lot of them are in aerospace and defense, the majority, but also a lot in the automotive industry. So yeah, just to say that Capella today is really a reference in the world of systems engineering. And the reason why we're here is, as I said, it's a reference, but also as an Eclipse project, it was really thought to be an open platform that you can easily customize, extend, and connect with other tools. So on the left, you see some intrinsic extensions. So members of the Capella ecosystem who develop their add-ons to model things that aren't included really in the core version. So we know some companies that developed add-ons to, transition to model systems or subsystems, well, transition from a system model to a subsystem model, so that way to design systems of systems, to model cyber security scenarios, that kind of things. And also, well, we, Obeo, but also a lot of our partners have built a lot of interfaces between Capella and other tools. So you see ANSYS Model Center, MATLAB, Team Center, OSLC-based ALM tools, that kind of things. So, yeah. Besides that, Capella relies on a modeling technology that is more general, called Sirius. It's a tool that makes it possible to build your own meta model, your own semantic, and then rely on that to build your own models after that, so you can really easily build a custom modeling tools. It's the technology on which Capella relies. And it has another application in the field of MBSE, which is coming. It's another Eclipse project we're working on. I think it's one of those talks here. Yeah, on the top right, the director, Cedric, may have a talk about SysML-v2 modeler. So SysML-v2 is an upcoming industry standard in the field of systems engineering, and he's working on a serious-based modeler of that. So you see a couple of other talks here that you're welcome to attend if you want to know more about the technology on which Capella relies. And yeah, here is a screenshot of what the director Cedric is working on. So this SysML-v2 modeler. Yeah. Oh, sorry, I can. So are there any questions?
No worries, no worries. So, any question? Yeah, so maybe there was a first question there.
Thank you very much. Basically, you already answered some of my questions with your last slide. I'm kind of confused among SysML v.2, respectively Capella, respectively Eclipse Arc-E. At least Eclipse Arc-E and Capella seems to me kind of competitive or competing tools or complementing tools. You have to answer that question. And why I should use Capella when I have a SysML-based modeler, right?
Yeah, so the first point about Capella versus Arcadia, it's just a way to dissociate the method that is applied and a tool that really supports the method. So in theory, Arcadia is a method and Capella is a tool. And in theory, you could apply the Arcadia method without the Capella tool. But since Capella was really tailor-made to apply this method, it's recommended to do that. So that's for the first point, I think. Then about SysML, so there are several reasons why Capella doesn't use SysML, and it was mostly a design choice that was made by Thales back in the time when they decided. They first try applying SysML-based methods and tools and processes, but they quickly realized that they really struggled to have it accepted by their systems engineers. So they came up with this semantic and this modeling process that is really easier, really more natural. So I think this is the biggest difference between Capella and SysML-based tools. It's usually way easier to start with, and the barrier at the entry is really, really lower with Capella.
Yeah, so and Eclipse Archie, I mean, it's been an SDV project for a while, but we have not seen code yet. And yes, it is tailoring system-based model engineering designed exactly for automotive deployment. But until we see what is exactly about, and this is the thing about having a lot of projects with different maturity levels, we don't really know what the synergies can be. That's the first point. And secondly, in general, and this is from the Eclipse Foundation point of view, we'll never select, even if there is an overlap between projects, we will never select one or the other. But rather, we will try to foster the community and push the community towards working together. So we'll never choose one project or the other, even if there are overlaps. Yeah, I haven't seen Tom, but hopefully he'll be around. Any other question?
No, I'm just surprised, honestly speaking, because all the three, let's say, German premium OEM manufacturers, which I have as customer, they definitely go with SysML. So
well, historically, they have different tracks,
that might be,
and this is why both of them are definitely feasible.
I see the requirements, I see how they are modeled, and I see the SysML language evolving from 1.5 to 2.0, and they are all very happy to have variant management finally integrated. So I think the standardization is going to be definitely there. But at least this is what I see today.
And that goes through adoption, right?
And the idea of this project is to benefit from the two. So to create a journey when you benefit from the methodology, because inside SysML it's just a notation. You don't have any methodology. You have a palette with 100 of concepts and good luck. No, there isn't any methodology in SysML. There isn't. And that's a principle at the OMG to say SysML is just a notations and a format. And it is agnostic. And the idea is to bring the two value of the guidance of the methodology and the support of the standard with SysML v2. Exactly. Yeah.
So there was another question. You had a question, or was it answered? No. Okay. Any further question? And yeah, I mean, feel free to discuss this. This is, of course, so we are never going to say use that or use that other thing. So it all goes through adoption and like natural selection. Okay. So no remark or no point, then thank you. Thank you, Martin.